What's up, guys and gals? Darkdally here, and today we are going to continue on our quest to make electricity our bitch. Now, if you've tuned in to some of my previous videos, you may have seen this contraption that I built here. This I have entitled, it has a name now, it's the FCB09. This is the version 1, of course. This is basically, at its most basic description, it's a computer. It's a computer of sorts. Though it lacks any kind of processor, that is going to come later. I have plans to expand upon this computer. I need to rebuild it at another location where I simply have more room. I'm on Spectacle Island, I know, and there's all the room in the world here, but I also have an entire village built here. I'm getting near the build limit, and I don't want to have frame rate issues in a room with a computer that's as big as this, is going to be. Okay, so again, if you've seen my previous videos, Make Electricity or Bitch, specifically the one where I began describing logic gates, then you have seen this computer and you know some of what it can do. Let me talk a little more about it, because this really deserves a lot more than just a mention in one video. The reason I built this computer is to test other electrical things, and that's what this does. It is a testing platform where I can perform experiments. Basically, these switches allow me to move electricity around through here any way I want. Again, as you know, if you've seen some of my previous videos. What it has here, the wires back here go to various terminal conduits and switches, which I have pre-placed so that I can plug in any experiment I want. It's really set up for, like, you could say, plug and play. I can come back here and I can plug in any new experiment that I want. Oops, we don't need this wire. Now, previously I spoke about something I called backflow. And it's very important because knowing about it will make your working with electricity in this game either much easier or much harder. And basically I explained it as when you have more than one power source in different places, they will feed through the same circuit. And it can cause problems backwards in a circuit when you don't expect it. Power will be feeding backwards. Now, I've tried to demonstrate it here, and I think I could do a much better demonstration, but in doing so, I came across something weird, and that's why it's handy to have a machine like this. I can help you build your own machine like this if you're interested at all. Now, I will get to the backflow demonstration in 1 second. First, I want to say, I've seen other people build much more complicated machines than this. I've seen people build calculators, which was pretty impressive and damn commendable, I must say. So anyone who spends a time and effort to build a calculator within this system using logic gates and other computers. But here's the problem: they don't do anything. What's the point of building a calculator in the game? You know, the point is doing it, and then once you're done, then it's like, well, shit, I got this humongous contraption of 50 logic gates over at the Boston airport. Well, what am I going to do with it? I don't know. So this actually serves a purpose. This is a tester, and I'm building it slowly, piece by piece, which is the best way to do anything complicated, as I foresee this eventually incorporating a shit ton of logic gates. The processing system I'm designing for this is going to be made up of logic gates so that it can store, repeat, and execute commands. Now, on to this. As I said in my previous video, this building is on its own independent power. Settlement power comes in through here, through this wire. If I need it, I can connect it. Now, previously I stated that I couldn't separate them, that even with all these switches off, settlement power was still coming through. And that's true until I redesigned my settlement's power generation system, and now it doesn't do that. Let me demonstrate. Let's demonstrate it here first. Let me demonstrate to you the very basic idea of what I called backflow. This is how you can see it very simply. Not that you need it demonstrated simply, but this is not a humongous computer with wires buried in the wall that you guys don't know what they do. This is something you can physically see. This is a great visual experiment. We have two generators. We have a 3-power generator and a 5-power generator hooked up to 9 lights. Now, when I turn these on, we're going to see 8 lights light up, because there's 8 power here. Each generator is hooked up to a switch. So you would think if I turned off this switch, it's going to cut off their 3 power, right? I would assume, I would bet money, 90% of Fallout builders put switches like this, assuming it'll just turn off their generator. Just assuming it would, because why the fuck wouldn't it, right? Why wouldn't this turn off this generator? It's the only thing connecting this generator to these lights. And so people put stuff like this in, and then when shit goes wrong and their humongous web of logic gates, they don't think that it's the simplest thing like this that's causing it. See that? Nothing happened. Okay, now let's turn off the 5 power generator. Surely this will turn off 5 lights and we'll only have 3 lights left lit, right? This switch is the only thing connecting it. Nope. And that, guys, is the simplest way I can demonstrate what I call backflow. These lights are getting 8 power, even though the only connection to this generator is turned off. So I have 2 main theories to why this happens. Either A, I think this is quite likely. The Falllout system calculates everything in a circuit as one whole deal and then divides it up and radiates power out from the center. I can show you on my computer back in there. That's one thing I've discovered using experiments on it, is that the power does radiate from the inside out, and I can demonstrate that later. My other theory is backflow, which means, okay, this switch is on. So there's electricity traveling through this wire to the generator. And as there would be in a real life circuit, there would be power here. You know, even in a real life electrical circuit, there would be voltage right here. No current, but there would be voltage right here. Even in a real life circuit, there would be voltage here. But somehow the Falllout system is getting power from the other side of this switch. The phenomenon I call backflow is basically just saying it's like the omnipresence of electricity, and there's no way to get rid of it. So that is demonstrated very simply. What I could have demonstrated better in my last video. Now, as we're running back, there's something I want to say. I feel that some of you may think I'm making this look too easy, as if I suddenly came up with this, like I'm some kind of prodigy and I just know everything about electricity. That is not the truth. And I mean, obviously it's not the truth. I'm sure you guys know that. I don't want that to come across as what I'm saying. What I haven't shown you guys is all the hours of frustration and all of the notebooks worth of paper I have wadded up and thrown away trying to design logic gate systems and things like this. And that's why this machine exists, is so that I can test these things out. So I want to put that as a disclaimer. I have worked every bit as hard as everyone else to design all this shit, and I've dealt with all that crap. The difference is, when I encountered bugs in logic gates, I said, my thinking must be wrong. My diagram is faulty. It needs to be debugged. And so I would go through my diagrams backwards and forwards, and lo and behold, as I started catching logic bugs in my things and fixing them, my logic gates experiments worked. So here we are with this. I'm going to show you first. Let's show you what I mean by power radiating out from the center and dividing up evenly. This kind of goes with my omnipresent electricity theory, that it's just always there and radiates outward from the center. Let's turn this switch off. We now have electricity only flowing to this side of the computer. If you guys want more information on this computer, or even how the fuck it's built, well, I will go into that. Let's introduce power to this entire side of the grid here, okay? That was already on. This is also being run by 8 power, a 3 and a 5. Why do I keep doing that? I'll show you why. It's a great number. It's 9 minus 1, so it leaves me one empty block here to play with. It works well for this system. Now, as I start turning on these switches, the power is actually going to choose to vacate these lights and go join these lights, because it wants to be equal and it wants to radiate out from the center. Like, well, let's say I enable it to come this way, which I can do. Okay, I'm letting it come in through the back. See, it's coming through the back. It's working its way to the middle. It wants to come in the middle, and it turned off these lights to do that. Let's go ahead and turn this off. So this goes back to normal. Now, once I enable it from the center, it's going to start flowing out from the center, because that's how it wants to flow, and it will naturally always divide itself up evenly, stealing power from here to turn these on. Okay, guys, stick with me because there's a little more to come. That brings me to my next topic. The creation of this machine was born from the want of a load tester for my generators. Now, you guys may notice I have some basic electrical knowledge, and if you've noticed from some of the lingo I've used, I do have some experience with electricity. Not as like an electrician. I don't want you guys to think that I'm hot shit. I'm a mechanic, so I know some about vehicle direct current electrical systems. So I know a little bit. So when I say load tester, I'm referring to what a battery load tester would be on a car, which is where what it does is it puts stress on the battery. Basically, if you want to see, okay, you know, how much cranking amps can I expect out of this battery? Well, this tester, what it does is it puts a huge load on it, and then it comes back with a reading and says, okay, this is what the battery could withstand. So that's my idea of doing a load tester here. Basically, in this application, what it's going to do is it's going to tell me how much power is left in the generators, because the game doesn't tell you that. This game tells me that I have 61 power in this settlement, but I start building elevators and shit, and, you know, power doors, I don't know what's left. Sometimes it's nice to know, and then the number turns red, and then you're like, well, fuck, how much more do I need? How much did I use? I thought it'd be handy. That's where this machine came from. Like I said, I'm all about practical applications. Now, and don't get me wrong, I commend anyone who had the patience to build a calculator, but that's beyond just having fun doing it. There's no point. I wanted to, if I was going to build a computer, and I waited up until now to do it, it was going to have a point. This has that point. The idea was to load test a generator by lighting up these lights, because each of these lights acts as a load. Each of these lights pulls 1 power from the generator. Hence, the 8 power in the generator only has enough juice to light up 8 lights. This tells me, hey, there's 8 power left in my 8 power system. Let's say I turn on the terminal. Oops. One of those disappears because the terminal is drawing 1 power. So now, this is basically, and a viewer was asking me about the load tester I said I plan to make. This is how I imagined it to work in my head. And here, it's accurate because it's showing me there's 7 power left, and that is correct because this terminal is using 1 power. Now, there's a problem with that, and that's one place this machine comes in handy, because it allows me to do such a wide array of tests. I can test all kinds of things, and one of my questions was, I have noticed power acting differently at a distance. For instance, as you saw on this experiment over here, there's no way to shut off these generators. Now, if one of my theories about how electricity works in this game is correct, and that power radiates out, it's because of the proximity of these generators. Because I want to show you something back over here. I remember I said earlier that I moved my power generation for the settlement. And now this is working differently. Hey guys, this is how we learn stuff, and I'm learning stuff too. I'm showing you this as I learn it. This computer is a humongous help. Again, I love this thing. Right now we're using the power from the basement. As you know, as you can see, there's the 8 power. Let's go ahead and shut it down just a little bit. Off, off, on. Okay, that's what we want. Turn this off. So now we're only getting 6 power. I mean, it's still producing 8 power down there, but I have shut down its ability to bring any more than 6 power up here. Now I'm going to do what, according to the test I showed you out there, I shouldn't be able to do. I'm going to bring in power from the settlement, and now I will be able to turn it on, off, and separate it. And honestly, guys, I'm not sure how, because this contradicts my theory of backflow, which I have mentioned earlier. And my only guess is it works on proximity. Here we have brought in settlement. That 61 power from the settlement is now coming to this switch, and it's not coming through it. This right here contradicts the test that I did out there. Remember where I turned off that 3 power generator, the 3 lights were still lit. Right here we already see I have the off switch to the settlement, and its power is not coming through. When I turn it on, here comes the power from the settlement. Let's go ahead and shut this down. This shuts down the generators in the basement. And see, it's actually working. Here I have been able to separate it. So I'm updating my theory. I'm kind of leaning towards, don't get me wrong, power does flow through those wires. Power always flows behind the background, as the test out there does show. This test here, however, is showing that it could be a matter of proximity, because these generators that power the settlement are farther away. They're over here in this building. So, I'm mentioning some of this because of my load testing experiment. Let's go back to that. That's still an endeavor that I'm still pursuing that. But there's more variables I have to knock out of the way. This computer can help me find out some of those things I need to know, because I can show you how to build something like this, or to the viewer who was interested in building a load tester to test the power in his generator, I could show you how to build something like that. But until I know for sure, because as you saw, let's go ahead and turn off settlement power, which I can't believe it's now letting me divide it. This is how we learn stuff, you know. Let's turn back on power from the basement. Oh, no, see, now I'm getting settlement power. Because there's only 8 power in the basement, this is displaying 18. There you go, guys. That is it in demonstration. I'm not even going to cut that. I'm not even going to edit that out, because that's how wonky this is. It's not a bug. It's just something we haven't figured out yet. I'm not going to blame it on the game. It's just something I haven't figured out yet. That's why I built this machine. There couldn't be a better example of how weird this is. When I pull this wire, those lights will go out. Okay, guys, there you go. That's why I'm still trying to figure this out. That is very well demonstrated. Thank you, game, for doing that right then and there. There is some mysterious force which makes power flow behind the scenes. So keep that in mind. Keep your power systems consolidated and on one end of the circuit. That goes to any wires going into the middle of the circuit, because those wires could potentially be carrying power as well. Now back to the load testing thing I was saying, I still need to iron some things out, because as you see, when I start flipping on switches over here, it's going to start stealing power from over there. Well, let's turn this off. It likes to stay even, so I doubt it's going to, yeah, it's not going to take that power because it wants to stay even. But I will say this, as I start turning these switches off, it will start migrating over there. Oops, if the switches were on, it would, see? And so, when it comes to load testing, here's what I'm saying. I'm using these lights to drain the generator. Say I put this at some random point in the settlement, and unbeknownst to me, it starts deactivating other things in the settlement to light those lights. We're getting an inaccurate reading. So first, I need to nail down exactly how electricity moves. Again, that's where this machine comes in handy. It shows me how electricity moves. It shows me it radiates out from the center. So guys, that's still a work in progress. A lot of other things are in progress. This machine has a version 2.0 coming up. I hope you guys enjoyed watching this, and you learned some, as I obviously just did, about how electricity works in this game. I hope you appreciate this computer. If you want to apply it yourself, we can work on that. If you want to help me improve this, we can work on that. This computer has a purpose in the game, and that it helps us better understand how the game works. Alright guys, that's it for me today in this episode of Make Electricity Your Bitch. I'm Darkdally. I will catch you guys next time.